Welcome to This Explainer. Listen, right out of the gate, I want you to completely change how you view your Cambridge Computer Science exams, especially the 9618 Paper 2. Whether you're currently grinding through syllabus codes 0417, 0478, 0983, 0984, 2210, or you're pushing into the really advanced 9618 A-level territory, the entire game changes for you today. Seriously, I need you to stop thinking of this as a traditional test. You know, the kind where you just nervously sit down, grip your pen, and try to write down absolutely everything you can remember from a textbook before the clock runs out. We are throwing that mindset away. Instead, I want you to imagine, vividly, that you are walking into a high-stakes, multi-million-dollar corporate boardroom. You aren't just a student anymore. You are the senior strategist. And the examiner, they are the board of directors. Every single answer you write on that paper is a $1,000,000 pitch. Think about it. You wouldn't walk into a corporate boardroom and just start throwing random unconnected facts at the CEO, right? Of course not. You would justify every single claim you make with rock-solid data, structured reasoning, and a clear, undeniable strategy. And guess what? That is exactly what the academic benchmarks for Cambridge Computer Science require from you: logical, structured reasoning. So today, we are going to master this boardroom pitch. We're going to completely overhaul how you write your answer. Okay, take a really close look at this number on the screen: 15%. Did you know that the benefits and drawbacks of cloud computing accounts for approximately 15% of the total marks in Paper 2 of the Computer Science 9618 syllabus? That is massive. That is a gigantic chunk of your final grade sitting in just one single conceptual area. It's literally the difference between an A and a C for some students. But here is the fascinating and honestly kind of frustrating part. Year after year, without fail, candidates leave these marks on the table. And it's not because they don't know what the cloud is. You use the cloud every day. You know what it is. The problem is they don't know how to pitch its benefits and drawbacks to the examiner in a way that actually secures the maximum marks. They treat their answer like a casual conversation with a friend rather than a technical evaluation for a board of directors. Mastering this 15% isn't just about memorizing some cloud computing trivia. It is entirely about mastering the exact technical methodology the examiners are actively looking for. We have to give them exactly what they want. Okay, let's dive into this. Here is our official boardroom agenda for today's strategy session. First up, the cloud challenge. Then we'll look at core principles. Third, we are going deep on the method mark strategy. Fourth, we'll uncover the examiner traps. And finally, number 5, the evaluation framework. Let's start with Section 1, the cloud challenge, and specifically, how to completely avoid the dreaded data dump. Now, what's really interesting about what we're looking at here is how perfectly it illustrates the massive gap between your average candidate and a top-tier candidate. Imagine a dynamic split screen. We've got a real Cambridge Computer Science past paper question, specifically from code 9713, right in front of us. The tension in the exam room is sky high. The clock is ticking down relentlessly. The question is asking candidates to evaluate the benefits and drawbacks of migrating to a cloud computing architecture for a specific multinational company. This right here is where the ultimate challenge begins, and frankly, where most candidates completely drop the ball. And they don't fail because they lack the knowledge. They fail because they provide what I call a raw data dump. They just start listing generic facts. They write things like, well, the cloud uses the internet, or the cloud is cheaper. Guys, those are incredibly superficial observations. The board of directors is not going to be impressed by that. Let's look at 2 flawed student avatars to really break this down. On the left side, we have Alex. Now, Alex's pitch is just covered in red pen marks from the examiner. Why? Because Alex overloads the answer with raw computer science facts. Alex writes this massive, sprawling paragraph about server farms, virtualization, binary representations, but includes absolutely zero analysis of how any of this actually benefits the specific company in the prompt. It's a total info dump. The examiner doesn't care that you know what a server farm is if you can't tell them why it helps this specific client. Then on the right side, we have Sam. Now, Sam has a different problem. Sam rushes. Sam completely panics and misses the command word requirements entirely. The question specifically said evaluate, but Sam just wrote a describe answer. Sam completely missed the required assessment objectives. So how do we fix this? How do we go from red ink to full marks? Top students use what we call the PEEL framework. P-E-E-L, point, evidence, explanation, link. You make a precise point about a cloud benefit, you provide concrete evidence from the technical architecture, you give a detailed explanation of how it actually works, and then, and this is the absolute most important part, you link it back to the specific context of the prompt. That is how you win the boardroom pitch. Before we continue, subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along to Section 2, Core Principles. Let's talk about cross-topic connections. All right, we are leaving the flawed pitches of Alex and Sam in the rearview mirror, and we are stepping directly into the minds of the top 1% of candidates. Listen, the theoretical architecture of the cloud computing topic isn't just some isolated island of knowledge sitting off by itself. The syllabus strongly emphasizes that top-performing students exhibit a connected, conceptual understanding that is highly transferable to totally unfamiliar contexts. What does that actually mean for you? It means you aren't just memorizing what cloud computing is in a vacuum. You are demonstrating how it interacts with networking, with security protocols, and with algorithmic efficiency. The principal examiner reports highlight something absolutely crucial here. Candidates who explicitly reference cross-topic connections achieve significantly higher marks. It's a game changer. When you pitch the cloud, you shouldn't just say it's good. You should be referencing exactly how its implementation affects data transmission speeds across a network, or how relying on remote servers impacts the space complexity of local operations on the user's end. Now, pay very, very close attention, because this is an official examiner alert. The principal examiner reports reveal that candidates consistently, and I mean every single year, confuse key terminology. You literally cannot build a strong, logical, causal relationship if your foundational terms are weak or incorrect. The board demands precise definitions before you even attempt to build your argument. If you're going to go into the boardroom and talk about latency as a drawback of cloud computing, you must first precisely define what latency actually means in this specific context. If you want to discuss elasticity as a major benefit, define it clearly. Don't ever assume the examiner knows what you mean or that they'll give you the benefit of the doubt. Prove to the examiner that you know exactly what it means. This level of precision is the absolute bedrock of the academic benchmark. It shows the board that your data interpretation skills are razor sharp and that you are genuinely ready to perform complex evaluations. All right, let's jump into Section 3, the method mark strategy. This is all about securing those marks for your process. I am officially putting on my senior strategist hat right now to guide you through the method mark strategy. In Cambridge computer science exams, and I'm talking especially about paper 2 here, you're very often faced with multi-step calculations, complex data interpretation, and tricky algorithm tracing. A lot of students find these incredibly intimidating because they only focus on the final answer. They think, if my final answer is wrong, I get a 0. But in our corporate boardroom, the process matters just as much as the final outcome. Method marks are actively awarded for showing your systematic processing. Think about it. When you're dealing with cloud architectures, you might need to extract data from binary representations, perform complex calculations on bandwidth limits, and then draw evidence-based conclusions from that math. If you don't show the board your method, you don't get the funding for your pitch. It's that simple. So your crucial focus needs to be on following this exact, foolproof procedural framework. Here are the 5 definitive steps to algorithmic thinking that will secure you every single available method mark. Step 1. Deconstruct the question. Before you write anything, what exactly is the command word asking you to do? Evaluate, describe, calculate. Step 2. Extract relevant data. Systematically identify and pull out the key data elements given in the scenario. Step 3. Select the analytical framework. Ask yourself, are we evaluating time complexity here, space complexity, or maybe network speed? Choose your weapon. Step 4. Execute with clear notation. This is exactly where you write out your step-by-step decomposition and your calculations clearly so the examiner can follow your brain's logic. Step 5. Present correctly. Use the correct, formal terminology and verify your final results. This step-by-step decomposition is exactly how you demonstrate appropriate data structure selection and efficient logic. It is, without a doubt, the ultimate computer science success blueprint.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4, Examiner Traps. How to avoid the absolute top mistakes. Consider this your internal threat assessment brief. Listen, we have painstakingly scanned through years and years of Cambridge Principal Examiner reports to identify exactly where candidates hemorrhage easy marks. The examiners literally publish documents telling us exactly what they do not want to see, yet thousands of students fall right into these exact same traps every single exam session. It's wild. In the context of evaluating cloud computing, or honestly any complex algorithmic problem, there are hidden pitfalls that will completely dismantle your boardroom pitch if you aren't vigilant. Let's look at the data source and extract the core trends of failure so you can avoid them entirely. This brilliantly illustrates the top 3 mistakes found in the reports. Mistake number 1, students forget to check overflow and edge cases. Look, whether you are dry running an algorithm or evaluating the absolute storage limits of a massive cloud system, you must check what happens at the extreme limits of the system. Does it break? Does it crash? You have to know. Mistake number 2, forgetting boundary conditions. This is similar to edge cases, but specifically, what happens exactly on the threshold of a specific condition being met. Top candidates always check the boundaries. And mistake number 3, and guys, this is the absolute biggest one for extended written responses. Answers are not specific to the context given in the question. The boardroom demands context. If the question prompt is about a hospital migrating its sensitive patient data to the cloud, and you spend your answer talking about the cloud benefits for a generic video game company, you will score 0 marks for context, I guarantee it. Your evidence-based conclusions must solve the specific problem presented in the prompt.
I actually want to pause and challenge you directly right now. Think about the very last past paper you completed. Go ahead, visualize it. Look at a flawed sample paragraph in your own study notes. Can you find the flaw? I'll give you a massive hint. The sentence losing marks is almost always the one that sounds like it was copy-pasted straight out of a textbook or a revision guide. Be honest with yourself. Are your answers totally generic, or are they specifically evaluating the given context? In our interactive workshops, we actually set a literal 30-second timer on the screen, and we force students to speed write one perfect Peel paragraph, point evidence explanation link. That link at the very end, that is the magic. That is where you prove to the examiner that you are actively thinking about boundary conditions and edge cases specific to their exact scenario. Don't be an Alex making an info dump. Don't be a Sam who rushes and misses the point. Be the strategist.
Which brings us perfectly to Section 5. The evaluation framework. This is where critical analysis happens. As you move into the higher order assessment objectives, especially when you are tackling the 9618A level, simple recall is just not going to cut it anymore. It's not enough to just remember facts. You are expected to demonstrate high-level critical analysis. Real problem solving uses a very strict deconstruct, solve, evaluate sequence. You identify the given information, you break it into logical steps, you solve it systematically, you check it for reasonableness, and then, crucially, you make justified recommendations. You have to evaluate the alternatives. Is a public cloud genuinely better than a private cloud for this specific client's dataset? Are the drawbacks of potential network latency actually worth the benefits of infinite scalability? Let's look at exactly how we measure algorithm and system quality. This table right here, this is your ultimate cheat sheet matrix. We have columns for factor and effect on performance. When you are evaluating any approach, you must weigh time complexity. Ask yourself, how fast does this cloud operation or algorithm execute as the data scales up massively? Then you weigh space complexity. Exactly how much memory does it require to run efficiently? And finally, edge cases. How does the performance degrade under extreme or totally unexpected conditions? You absolutely must weigh these 3 factors against each other in your final pitch. You might confidently propose a solution with brilliant time complexity, but if the space complexity is so high that it blows past the client's budget, the board is going to reject your pitch outright. You have to compare these approaches side by side and justify your final recommendation with crystal clear working. Honestly, if you take only one single thing away from this entire explainer today, please let it be this exact quote, pulled straight from the Principal Examiner report. The assessment framework prioritizes analytical depth over superficial breadth. Let that sink in for a second. Really think about it. The examiner does not want you to list 10 different random benefits of cloud computing, giving each one just a tiny weak sentence. That is exactly what superficial breadth is, and it earns you average grades. What they actually want is for you to pick the 3 most highly relevant benefits for the specific scenario they gave you, and then evaluate those 3 things with massive, undeniable analytical depth. They want the precise definitions. They want you to map out the causal relationships. They want to see the cross-topic connections to networking and security. That, right there, is exactly how you max out the progress bar on your mark potential. Now, to help you actually retain this massive amount of technical methodology under exam pressure, here is a super quick, incredibly valuable memory hack, straight from our top-performing students. Create your own mnemonic using the first letters of key cloud computing terms, or even use it for the Peel and method mark steps we discussed today. For example, to remember those 5 crucial method steps, deconstruct, extract, select, execute, present, you could just use the phrase, data experts solve every problem. DESEP. By taking a few minutes to encode this sequence into your memory right now, you won't panic when that exam timer starts ticking down. You won't freeze up. You will simply rely on your systematic processing to guide you through all the noise and secure those marks. So, Let's recap. We have covered command word decoding, the Peel framework education, and the time management matrix for evaluating algorithms. Implementing these exact strategies is how you successfully turn a raw, messy data dump into a sleek boardroom-ready pitch. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Now, I want to hear directly from you. We are wrapping up today's boardroom strategy session, but honestly, your work is just beginning. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.